Hello everyone, welcome to this video. In this video, we are going to learn a very important application of prefix sums, which is called as the range sum query. So let's get started. Okay, so after now we know what prefix sum is, what this particular problem is asking us to do. Let's say we are given an array 1, 2, 3, 4, 5, 6, 7, and then I also give you a bunch of different queries. So in every query, I will give you two indexes L and R, and I will ask you what is the sum of all the elements in my list between elements L to R inclusive. The indexes is 1, 2, 3, 4, 5, and 6. My first query can be give me the sum between elements 1 to 4. So if you see, between 1 to 4, we have elements 2, 3, 4, and 5. And the sum here is 6, 9, 14. So you return me 14. My next query can similarly be, let's say, 0 to 5. So sum between all the elements 1 plus 2 plus 3 plus 4 plus 5 plus 6, which is 21. So this is how we need to answer our different queries. In our first thought, it comes like you can simply write a for loop for each a particular query, right? You can just do between L to R and maintain a sum. But this particular method will be very, very slow. For example, if I give you Q queries, in each query you are doing a computation of order of n. To process multiple Q queries, you will take Q into n time. This will be my time complexity, right? But your space complexity for each query will be just like order of 1. You are not storing, you are just maintaining a running sum. So like you can think of it as like to answer Q queries, you need Q variables. So probably it is order of Q, which is like still very, very low. Definitely you are saving up on space, but your time complexity is too much. And that's where the concept of range sum query comes in prefix sums. So notice that if I give you an array 1, 2, 3, 4, 5, 6, and you also compute a prefix sum array of this, which will be 1, 1 plus 2, 3, 6, 10, 15, and 21. And these are the particular indices. Now, if I tell you, give me the sum between 2 to 4, what you can simply do, you can, let's name this array as P. You can simply do P of 4 minus P of 1. If I need to find the sum of all the elements between 2 to, let me choose a different color. If I want to find the sum between all the elements between 2 to 4, my sum is 3 plus 4 plus 5, which is 12. And if you subtract 15 minus 3, you'll also get 12. And you are able to do this in order 1. So to process each query, you just need one particular lookup, which is this. And why is this happening, right? So let's try to intuitively understand this. So let's say this is my initial array. What is stored in the prefix sum? Let's try to understand that. First element is equal to A, second element is equal to A plus B, third element is equal to A plus B plus C, fourth element is equal to A plus B plus C plus D, and the fifth element is A plus B plus C plus D plus E, right? Now, if I am saying that go ahead and calculate the sum between sum of C plus D, you can easily see that if you subtract this particular value with this particular value, you will get the sum of a plus b plus c plus d, right? So you know that till the fourth index, you have a cumulative sum of a plus c plus d. Now I just need to subtract the cumulative sum. I just need to cut off this prefix. And where will I get this prefix? I will get this in the second index. Second index will have a total sum of a plus b. So this is the entire concept between range sum query. In just order of 1, you are able to calculate the sum of any sub-array, right? And this is very, very powerful. So let's go ahead and try to implement this. And before implementing, we'll also learn a very important technique. We can calculate the prefix sums of a particular array in place itself. So what I mean by that is, let's say you are given this particular array 1, 2, 3, 4, 5. You can replace this array with its own prefix sum. How you can do that? The first element will stay as it is. To calculate the second element, you can just do a sum of the previous element plus the current element. It will be 3. To calculate this element, you can do a sum of this current element plus the previous element, which is 6, 10 and 15. So you are not creating a new array here. You are just utilizing the space of your initial array. So you can do this in all the problems where you don't need the initial array. You can just do this simple optimization and calculate your particular prefix sum array in place itself. Now let's try to implement this. So we have been given an array nums and we have to handle multiple queries of the following type. The queries will be of this type. We have to calculate the sum of the elements of numbers between left and right, inclusive left less than equal to right. And this is given in a class method where in the sum range function, we will be given two values left and right and we will return the sum. So this is what we learned just now. What we can do, I'll do a initialize array called as pref, and I will initialize is to be num, and then I will iterate from the first element because the from the first index, because the first element which is at 0th index will remain as it is, and I will replace the initial array in place. So let's take out the length of my self dot prefix. Now what I want to do is my ith element is equal to ith element plus the previous element, which is I minus 1. So this will build my prefix sum, right? Now let's learn about one more edge case here. If I tell you, give me the sum between 0 to 3. 0, 1, 2, 3, 4, right? So according to the formula, if we need to calculate the sum between L to R, my formula is prefix of R minus prefix of L minus 1. But what if L is 0, right? Then there will be an error. You cannot calculate prefix of minus 1. There is no element behind this. There are techniques where you can initialize a prefix array of size n plus 1, but like in this particular problem, we are not doing that. So we need to handle this case separately. So if my L is equal to 0, then my answer will just simply be prefix of R, right? Because we don't need to subtract anything. So let's go ahead and try to implement that. If my left is equal to 0, then I can then I can simply return prefix of right, or else what we can do, we can return prefix of right minus prefix of left minus 1. Let's try to run this and see if this works, if there are any mistakes. So yeah, we have to access it using self.prefix because this is an object, and let's see if we have resolved all the errors or not. Okay, so now this works. This is a given array and our first query is 0 to 2 and we get a sum of 1, similarly minus 1 and then minus 3. We'll try to go and hit the submit button. Okay, yeah, so now this works, right? So now we have learned this particular problem. We will solve one more interesting problem which is an application of this, and this is a website called as Codeforces, and let's try to find the solution for this particular problem. So this problem is called as flipping game, and let's try to read this. So Lahab got bored. He invented a game to be played on paper. What he does is that he writes n integers a1, a2, a3 till an, and each of these integers can either be 0 or it can be 1. And he's just allowed to do exactly one move. He chooses two indices I and j and flips all the value for their between I and j. So all the zeros become ones and all the ones become zeros. And the goal of the game is that exactly after one move, we need to obtain the maximum number of ones. So we need to write a program to solve this little game of Lahub that he has made. And we can see that there can be around 100 integers given to us. And yeah, so if you take the first example, there are 5 integers, 1, 0, 0, 1, 0. So what Lahub can do, Lahub can choose this particular subarray. It can flip all of these zeros to ones, and you can see that finally the total sum is coming out to be 4, right? So this is just an application of what we learned. What we can simply do in this problem is we can calculate a prefix sums of all our array given, and then we can quickly get the sum of a particular subarray in order of 1, right? Now a very interesting observation that you can do in this particular problem is when you are flipping a particular subarray to the final sum, let's see what we are doing. We are converting all the ones to zeros and we are converting all the zeros to ones. So converting a 0 to 1 is a plus 1 for us. We are adding plus 1 to our total sum. Similarly for this particular 0 as well. But for all the ones, we are kind of decreasing it to 0 and thereby decreasing the sum by minus 1. So what if I replace my first given array with this? What I'll do, I will replace all the 1 with minus 1 and I will replace all the 0 with a plus 1. And I'll make a new array. What this new array will tell me, let's say my initial array is 1, 0, 0, 1, 0, and I need to find one subarray which has like the maximum benefit, right? So what I do is I'll make a new array. 1 will be replaced by minus 1, all the zeros by 1. Now in this particular new array, I just need to find a subarray which has the maximum sum, because that particular array will give me the maximum advantage of this. And how you can do it? You can just simply calculate the prefix sums, right? You can calculate the prefix sums, go over all the subarrays. First of all, let's find out how many subarrays will be there. To calculate this pretty quickly, let's say I have an array of A, B, C, D, E. So like for example, let's calculate all the sub-arrays which are starting with A. It can be like AB, ABC, ABCD, then ABCDE, right? And also simply A as well. So for A, all the sub-arrays starting with A, you will have 5 possibilities. And then you will see for all sub-arrays starting with B, you have 4. And then 3, then 2, and then 1. So this is basically n into n plus 1 by 2. This is the number of sub-arrays you can have for an array of size n. Now, what I'm saying is that you need to find a sub-array which has the maximum gain, maximum benefit, right? So, after you calculate the prefix sums, you can easily iterate over each sub-array and then find the value of the sum in order of 1, right? And then you can easily find the gain here. So, the time complexity of this particular solution will be order of n square, which will easily pass our time limit. So if you see, the time limit is 1 second and we are given around 100 elements. So we are just doing 10 to power 4 computations, which is like pretty fast. Now you can also do this particular problem in order of n. I will encourage you guys to pause the video, think about it, and come up with this solution on your own. Okay, so hoping that you've paused, you can look up this particular solution. Is called as the Kadane algorithm. What this algorithm does is, it will tell me what is the maximum sum sub-array in order of n. So if you have an array of 1, 2, 3, 4, 5, 6, and you need to find out like which sub-array has the maximum sum, right? This is the best algorithm out there, which is working in order of n. We'll be covering this algorithm in detail in our future upcoming videos, and I will encourage you to go ahead and solve this problem on your own and try to get an fully working solution for this. So thanks for watching this video. Keep coding and see you in the next one.